Excellent. So I already said a basic background of our organization, but to give you some sense of scope and scale, we have about 45 people or so spread between Massachusetts and California. We do research on learning, and we build lots of materials, tools, resources that are technology based to help students and teachers in K-12 education for the most part. Lots of middle school and high school resources that you can find for free, as I described. And we do research on understanding what they do for learning. And we'll talk a little bit about both of those things today, focusing in particular on what we're doing for data science education, which we've been really focused on for the last 7 years or so. And within that, you'll see examples of resources and ideas that are coming from a number of different National Science Foundation funded projects that we're doing both within our organization and in collaboration with really lots of others around the country, universities, nonprofits, and the like. And I think that exemplifies the fact that we have been spearheading, but not completely owning, but moving the field forward on data science education for all this time. But it's a growing field, as this is an example. Lots of the things that we can talk about as we go along are examples of how this is really an important nexus of what we all know is essential, the fact that data and data science are everywhere today, and what we are all learning slowly but surely, which is how best to bring that across to students in K-12 education, because there's a lot that is still not known about how to do that. And we appreciate that all of you are on the forefront of figuring out what works and why, and getting the word spread across the country. So I won't say a lot more because Bill knows much more than I do about all of this, including some of the projects that he's been in the middle of that can show you how to use CODAP in lots of different ways, hopefully in your classrooms and teaching situations.
Okay, so a host will have to let me screen share. And basically, I want to set a bit of context with what we mean by data science education and show you some things about this piece of software that I've been working on for quite a while now. Where do I see that? That's the one. And I have this Google Doc that you can go to if you want, but you don't have to. And I'm going to chat that link in the group chat. But you can also mostly read it as long as you know that's an L and not a 1. So how do you know when someone's doing data science? What's the difference between data science and statistics? So we've been thinking about that for a while. And there's a lovely paper. I say that though I am one of the authors, but I'm not primarily responsible for the paper, called Data Moves. So one of the ways you know when people are doing data science is that you see them making data moves. Well, what do we mean by that? So this document has some links in it for Concord Consortium, the CODAP website, and for CODAP itself. So I am going to go to CODAP itself. There it is. And if I wanted, I could open one of the example documents, and those are quite interesting. And the Getting Started with CODAP is a great way to introduce a group of students to using CODAP. But actually, I'm not going to open any of those. I'm going to use some data that I have in a CSV file, comma separated values. It's on my desktop, but you can also see a reference to it down here. So I'm just going to drag it into CODAP. Kaboom. There it is. Is this window visible to all of you? Thumbs up. Okay. So I'm going to get rid of that little text component, but many of you may have met this data set before. This is the people who were on the Titanic when it sank, and some basic information about them. Let's suppose that we have a question that we want to know the answer to. We want to investigate. Oh, I better not let you do that. I better do one that I practiced. So how does survival depend on sex and fair class? Admittedly, a possible question. And to do that, to investigate that, I could, of course, look through the data. And what we see in the classroom is that a lot of times students will just spend quite a while looking through the data. But we've got 1,308 people here, and that's not a very efficient way. So let's make a graph. One of the goals of both statistics and data science education is that students come to see graphs as tools, not as tasks to be done. So I made a graph, and each dot is one person. And if I click on a dot, the case table, this is called the case table, scrolls to that person. And these dots have just been arranged at random because we haven't told them where to go. The way we tell them where to go is by dragging an attribute to an axis. And when I let go, the dots all move to, oh, that last one just made it, to their appropriate place. And now we get a kind of a grim picture, don't we, of that more people died than lived. Suppose I just want to focus on those who died. So notice I'm dragging, I'm selecting. I've selected over here in the case table, you can see I've selected all the people who died. And what I want to do now is set aside the ones that I didn't select, the ones who lived. So I'm going to set aside the unselected cases. And now I've just got the people who died. So this is our first data move. And I think I wrote that down. We filtered out those who lived. And whoops, the next thing I said survival depend on sex. So let's see about sex. So one thing I can do is drag sex to the y-axis. And now I can see that of those who died, many more were male than female. And I should be writing this down, shouldn't I? And this is a full-featured editor, so kids can make nice reports in here, you know, more males died than females. But if we're having a discussion in a class, somebody is sure to say, yeah, but maybe there were just more males on the ship. So where's that at? And that might lead us to come back here and say, you know, I really don't want to set aside those who lived. I want to see everybody all at once. So let's do that. And now I've got both the died and the lived, and I can start to see the survival rate, can't I? Who had a better chance of surviving, men or women? If this were a
Women.
class. Yes, someone's saying something. Couldn't hear you.
Women.
And how do you, what gives you that clue?
The amount of women, the amount of men on the ship were much higher than the amount of women on the ship, and more women still survived with men than men.
Aha. And we could talk about that. And maybe we would want to come up with a statistic. How does this help? Now we can say, if you are women, if you were a woman, a female, you had sort of a 73% chance of surviving. Whereas if you, hello?
I was
Whereas
saying now this quantifies it.
this quantifies it, right? So that's one of our data moves, summarizing or calculating. We've calculated something. And I'm going to stop here with this example. I've put a link to the data in case you don't have, it's easy to find on the web, but you could continue this investigation yourself, or you could, if you're working with kids, you could have them do it. It's a fascinating investigation to do, and there's lots written on it for high school age kids that you can find. Now, I want to show you a really great way to get kids started with very data-rich investigations. So I'm back here in my, oh, I did want to show one other thing. I just wanted to show this. If I plot the age distribution here, so the dots are stacking up, there were lots of 45-year-olds, 41-year-olds. And if I put survived on the y-axis, and now you can see the distribution of ages. And if I select over here, notice how it selects in both graphs. I just wanted you to notice that. Because
William,
that, yes.
Sorry, quick question if you don't mind. So do the graphs kind of intuitively decide whether it's a quantitative variable, so going with a bar graph versus a histogram?
They do indeed. And
Awesome.
there are many circumstances where the decision is not what you wanted. And then you can come down here and say, no, I really meant that to be a number, or I don't think you'd do that for died and lived, but there are circumstances for that. That's a good question.
Awesome.
And one other thing I wanted to show you is putting fair class into the middle here, and that colors. So it's very easy to get more than two, we call them attributes, you might call them variables, into graphs. You can get even more than that. You'll see if you get into CODAP how to do that. Now, back to my, my second foray into CODAP, and I'll just start up another CODAP document. And again, I'm going to make a new document. And this time my data is going to come from a plugin or a portal into a very large data set, namely the NOAA weather data for the United States. Now, this rectangle here is not an intrinsic part of CODAP. It's something extra. We call it a plugin. And this plugin provides a portal to a vast quantity of data. And I live near this particular weather station. All of these little orange dots are weather stations that supply data to NOAA. And if I click on this one, now you see it says Metro Oakland International Airport. It says that I'm going to get hourly data, and I'm going to get it from 11:16 to 11:22. That's an estimate. I may not get that complete set of data, but let's see what I do get. So I say get data. And there it is. I got 99 cases or 99 measurements. And what do I have here? I have date, dew point, visibility, temperature, pressure, wind speed, wind direction, and precipitation. I can make a graph. Let's make a graph of when and temperature. Now I can see that I didn't get all the way to November 22nd. Probably the data hasn't migrated from Oakland metropolitan area airport to NOAA yet, but it will come along. So there's my data. And something I can do here to make it a little bit clearer is to connect the dots with lines. So we could talk about that data, but instead of that, I'm going to ask that we look at data for the same time period, but from someplace else. Somebody have a suggestion for where we might look at data?
Somewhere in Missouri.
Do you have a particular place in Missouri?
Just St. Louis, I think.
St. Louis. Let's see. St. Louis, Mo. That looks good. And it shows St. Louis Downtown Airport. Downtown Airport, I didn't even know there was one. So there we are, and I'll get data. Now I'm crossing my fingers here because not every weather station will produce data for the given time period that I'm interested in, but I'll give it a try. And it says I received 85 more cases. That's good. And did the graph change?
Yeah.
It's a little hard to tell which is which, isn't it? Unless you know something about Missouri or St. Louis in November. So I'm going to do this move that I did earlier. I'm going to put the where on in the middle. And now I've got a legend down here for Oakland versus St. Louis. And by the way, I can select these data by clicking on the legend. I can also do it. Oh, isn't this interesting? We have two parts to this table. We might say that we have the weather stations and the observations in two different, we tend to call them collections. And so each weather station has a number of observations. So this is kind of a hierarchical structure. And if I click on a station, then it selects in here. And if I go back to the map and zoom, rescale the map, you can see, I'm going to shift select here. You can see where my two weather stations are. Let's do one more weather station. What would you like to do?
Key West, Florida.
Florida. I heard Florida.
Key West.
Key West. All right. Let's see what we have there. Key West FL. There it is. Ooh, let's do Key West International Airport. Airports tend to have more complete data. There it is. Let's get data. And in a classroom, I would ask you to predict what we're going to see in our graph when I do this. Would someone like to make a prediction? Andrea, you're making motions like you're going to predict something here.
Yeah, I'm thinking here. I'm like, well, if we're talking about Key West, Florida, the temperature will not have a drop as much as definitely St. Louis, Missouri. So I wouldn't see a drop or a spike. It'll probably be what do we call, uniform.
Uniform, I like it. So you're kind of going in on the variability of the data, and I love that. So I'm going to do it. And which one is it? Well, let's see.
It's got to be the top
Key
one.
West, it's the top one.
Yep.
And what do you think of Andrea's prediction about the data? Pretty darn good. Yeah. So we have hourly data, daily data, monthly data. We have data that goes back to near the beginning of the 20th century. This particular station doesn't go back that far, but many of them do. So you can actually do some climate trend kinds of things. And of course, all of these geographic areas. I claim, and we have classrooms to prove it, that this provides a very rich and fertile ground for students to engage with data in a way that they wouldn't do in a typical statistics class. This is definitely what we might call a wash in data. There's so much of it. Okay, questions or comments about that? How am I doing time-wise? Should I be stopping?
It's 6:30. So if you have another part that you want to dive into,
I do?
okay, you might, yeah. Just
Okay.
I've got about 15 more minutes at most, or 10 minutes, I would say. We have some time for some questions.
Okay, 10 minutes is perfect. So I'm going to go back here and yet make another document. And once again, I'm not going to open a document. By the way, CODAP is document centered. So I can save documents. I can share them with other people. So you can make a document that you share with your students. The students get a link. They open the link and the document opens up and they can do whatever they want in that document. It's their copy of the document. So, and they could make a shared link that they give back to you to show their work. It's pretty. There's no login. There's no installation. Did I mention that it's free? I don't think I did. There are it's a very low threshold to getting started. So maybe you'll have questions about that. But I'm going to make a new document and I'm going to go to another one of these plugins. And I'm choosing it again because it's a portal into an enormous data set. It's the microdata portal. And we have places. So we can choose all of the United States or particular states. We have years. We can get data all the way back from 1860. And we have many attributes. So let's just scan a few here. There's some demographic attributes, some race, ancestry attributes, some work and employment attributes, income attributes. Let's get income total. And was there education somewhere? Where was that? There, education. So let's investigate the question, does education correlate with income at all? I bet you know the answer to this. Let's see if we can see it. So I'm going to get the data, and they're all going to be from 2017, and I'm going to get 1,000 people. So go get them. And there they are. Oh, and some boundaries came along here too. So you saw points on a map. It's also possible to have states or polygons on a map. So here is Texas, and if I select it in the map, it shows me all the 83 people who in this sample came from Texas. And by the way, you can put boundaries into your data too. All you need to learn how to do is how to write that formula where US state boundaries are provided by CODAP, and state is just an attribute that has the name of the state. I hope I'm I don't mean to be overwhelming you. What am I saying? Okay, so we've got all this stuff here. Let me get rid of the map. And let's take a look at the incomes. Okay, once again, oh, look at that. Somebody makes a lot of money, don't you think? Huh. Looks like a lot of people make a lot of money. Ah, yeah, so this is one of those strange census code things, right? They put this here when for some reason they don't have access to the number or it's not applicable. So we know how to deal with that. We just need to, I did it last time in the case table by going here and saying set aside, but I can also do it just in the graph. If I don't want to really set aside these people anywhere except in the graph, I can do it here. Hide the selected people. Ooh, that's ugly. Why are they all down there? Let me use this rescale option that you've seen me use already. And zoom, there's the income distribution. Okay, our question is, does that correlate? Is there any correlation with education? Well, let's make a graph of education. And I think I'll put it here. Okay. That looks interesting. So how about we take out all these people, because these are probably kids, right? They don't make much. Anyway, I'm not actually going to do this because I don't have time. But I want to put education over here on the vertical axis, as you've seen me do countless times already. At least I've lost count. And there's my income distribution. How can I compare? I seem to remember. Got a preference for mean or median here? Shouting. I hear people
Median.
shouting. Median, because it's not symmetrical. Okay, so there are the medians. By golly, they're in pretty much an order already. And if I look here, the order is that. So let me just write my answer here in big, bold letters. Yes. Okay, so that's my write-up, and I'm going to share this and turn it into my teacher. So here's my share thingy. I get a link to a shared view. I enable sharing. And now I could copy this and put it into the chat down here. And you could all open that and it would look just like I left it. Now, one last thing before I turn it over to Chad is in this, you will find a reference to a really great online resource, the book, Awash in Data, which I happen to have open here. And here it is. And a great thing about this book is it's focused on data science and it's got CODAP embedded in it. So you can actually do CODAP stuff in here inside the book if you want. And that's kind of fun. So I recommend highly that you take a look at this book, and maybe it's something that you'll want to have your students go through. Chad, back to you for summary.
Great, thanks, Bill. So that I think gives you a pretty good practical and ground truth view of some of the ways that we've been thinking about data science education at the Concord Consortium and with a lot of the folks that we've been working with. And I wanted to take just a second and cue off of the end of what Bill was describing, because Awash in Data is not only the title of this great ebook by Tim Erickson that we partnered with him to promote, but also an important concept that we think is under-recognized when people are working with data. I tend to talk more about data fluency than data literacy these days because there is a real tendency, and I think probably not as much in this group, but in many, to think about students as passive consumers of data in visualization forms or in formats that we've provided to them that are oftentimes, I guess for lack of a better term, I would say pre-chewed. Here are 2 columns of data. Can you graph these data? What do you see? Here is a graph, maybe a complicated graph. What do you notice? What do you wonder? Those are good questions. Don't get me wrong. But if that is all that you get, it's kind of like sitting and watching somebody else eat a beautiful meal and asking them what they thought of the meal. We want to give students the chance to really dive in and understand what it means to work with data. And what that means is manipulating it themselves and finding answers, oftentimes finding different answers than you knew were in there. If they're really working with data, there are probably 50 interesting stories to be found in that data set. And
I would say, Chad, that in the
500, exactly.
yes, in the weather and microdata,
oh my
there's
gosh, yes, thousands. And are any of them wrong? No, they're all true. Some of them may be more useful or more interesting or more relevant to one particular notion than another. But the beauty of it is that they are all real stories. They are all stories to be discovered by students. They are the ones that students discover are likely the ones that they're interested in. And that fact, all of those facts, are part of the essence of what it means to be doing data science these days. And it means, and as far as we've been able to sort of express it, it means feeling awash in data, to be in the thick of things, trying to understand and make sense of a data set that is more complex than you recognize in a lot of the things that we see in textbooks or standardized tests today. So we're encouraging people, and you in this group, and by use of tools like CODAP, to engage students with situations where they have lots of choices to make and lots of stories to find and lots of ways to dig into the data. And CODAP by its nature is designed as an example of a way to let students explore data dynamically in that fashion. And even some of the things that you saw Bill doing there that look like mistakes are part of the nature of data. So there's nobody making $9,999,999 a year. Well, there are some, but very few in that data set. But that's a data point that comes within this. There are missing data in some of the places that you saw, and missing is different than blank and different than zero. All of those kinds of things are part of the messiness of what it means to work with data today. And while we don't want to, and I've taught high school and middle school before, we don't want to overwhelm students in a way that they can't deal with something, but we don't want to hide them from the fact that data are inherently messy in this world either. And so finding the right balance of that and making sure that students have the ability to work with messy, complex, interesting data is really part of what's important for this. So part of the reason, I'm saying this all for context, because it's part of what we're recognizing is important in this. And also as context for why something like CODAP is so important, because you can do lots of basic things with lots of tools, but we think that there are few and far between opportunities to engage with data the way that the real world is bringing those data out. But we think it is possible, and we think that students should have that opportunity. And part of what I'm hoping you'll take away from this is that opportunity for your students. So Bill left some links in that short document. I encourage you to look through all of those. And we'll put another one in before we're done to our portal of free resources at learn.concord.org, where you can find these and really hundreds of other examples of model simulations, one day, 1 week, 1 month resources that are for science and math and other situations. And among those are a series of explorations with big or complex data sets as well. The dynamic data science examples are nice, and they're walked through in many cases in the AWASH and data ebook. But examples that can let students get into the thick of this. If you're interested in more, we're happy to, you can look on our website. We've got other resources of how we've been thinking about this too, including some white papers and reports from some convenings that we've done. I've been doing some writing on this too. And we've been working with many other organizations across the country, including Cameron's, to start to move this revolution forward. And so if you're interested in that larger picture, you can sign up for the Messy Data Coalition that we're starting to form at messydata.org as well, because we know that this is going to take a big village of all of us to move forward. And we're thankful that all of you are on the vanguard of that. So thanks a lot for your attention, and happy to answer lots of questions here as we go along. But mostly just excited that you're all here, because this is where it all is happening.